This is a huge talk, so I'm going to have to go through it quite quickly. I'm also quite aware that the slides may appear a little small for people at the back, so in a second, I've already got the slides online, so if you want to follow along kind of locally, you can do. But yes, it's my third party, and I'll cry if I want to, and I will warn you, I might cry at some point, purely because this talk is going to be half an hour about the trials, tribulations, the mess, the minefield that is third-party performance. I'm willing to bet you've all built a website before that uses one, if not several, third parties. And the reason we use third parties is probably because we lack the time, money, skills, inclination to build our own web font hosting service, to build our own analytics package. So we tend to lean on third-party providers for convenience, but in using that convenience, we actually relinquish a lot of control. So what I want to talk about today is what control are we giving away, how can we measure it, and how can we defend against it? If you want to snap a quick picture of this, that is the slide deck already, so if you're worried that the slides might be a bit small, please feel free to grab a copy of them. If not, I'll just start. So my name's Harry. I am from England, from the north of England, a place called Leeds, which is like London, but much nicer. I'm a consultant performance engineer, which basically means I make websites faster for my clients. And I've had a really fortunate, very, very fortunate career. I've worked for some really nice clients. Now, pretty much everybody on this screen has had some kind of performance issue that I've helped them with. And I would say over half of them have had performance issues with third parties. So the annoying, frustrating thing there is it's not even their fault that they're slow, right? It's somebody else's fault. It's my job to help clients identify and debug and ultimately mitigate this risk. When I was preparing a talk about third-party performance, my mind shot back 10 years now to a news story that came out of Australia. And this news story, there's some really striking parallels. This news story deals with parties, although not third parties. It deals with uninvited house guests, uninvited visitors, and it deals with severe financial repercussions. And all of those things are parallels to web performance. Apologies. That's coming out of the line out. That's the 3.5. I can't narrate this one either. Apologies, everyone. Let me just try it.
Well, it's the real-life risky business. A teenager holds an alcohol-fueled party for hundreds of kids while his unsuspecting parents are on holiday. 16-year-old Corey Worthington is now facing not only the wrath of mum and dad, but a $20,000 fine from police. I spoke to him a short time ago. Corey, thanks for joining us. The only question that I can think to ask is, what were you thinking?
I wasn't really.
Did your parents say you could have a party?
No.
So
they didn't.
Why did you?
I don't know, it was just a get-together with a couple mates at first, and then we thought we might as well just have a bit of a party, and then it sort of just got out of hand, and yeah.
I fucking hate that guy. I hate that guy so much. He's so unapologetic. But that last sentence, it just got out of hand. Like, yeah, no shit, man. It cost 20 grand. Just got out of hand, but then that made me think of something else. There's quite a parallel between it just getting out of hand at this party and in web performance in general. Nobody on purpose built a slow website, right? It's usually an accident. It's usually a lack of sort of a holistic view of the project you're working on. A client contacted me last year saying, hey, Harry, we've got a problem with our site. It feels a little bit slow, and we think it might be down to third parties. And I said to them, look, send it over. There's nothing I haven't seen. Nothing scares me anymore. Send it over. Unfortunately, this one did scare me, because this that you can see right now in view on the screen, this is what the developer had been building. This is the web page that they believed, and indeed had, spent their day building. The problem is, there's a disconnect. Once a site goes live, it looks very, very different to what it does locally. Your dev machine, your dev environment is usually quite compact. You know, it's going to be a fast machine running locally, but also you won't have analytics running. You won't be using retargeting. You won't be using your tag managers or your A/B testing tools. As soon as a tag manager kicks in and this site goes live, it's a very, very different beast. Oh, get comfortable. It lasts for a while. So indeed, the green bit is what the developers had built. This is what they did every day, and they knew that they were doing a pretty good job of it. But at some point, the site goes live, and a tag manager kicks in. Now, can you all do me an honest favor? Can you just raise your hand if you're not sure exactly what a tag manager is, and I'll give you a really quick introduction. Okay, that's most of you. This is terrifying. As in, what I'm about to tell you will terrify you. So, I like to explain the problem via a kind of a scenario, right? So you're a developer, you're at work, and your client or your manager asks you to put analytics, Google Analytics, on the site. So you copy and paste the snippet, and you do that. And then the next day, somebody else in marketing asks you, hey, can you install Optimizely? Or can you install this other thing? And you say to them, well, I can, but I'm kind of busy. I'll put it on Jira, and I'll do it tomorrow. And the marketing team gets a bit annoyed. Like, it shouldn't take this long to install simple tracking scripts. So somebody, years ago, invented a tool known as a tag manager. And a tag manager is where the developer just installs one small JavaScript file. Now that talks to an admin interface. Google Tag Manager, Adobe Tag Manager are examples. And this is where your marketing team log into an admin panel, and they've got basically a WYSIWYG. And they can copy and paste all the tracking scripts themselves. So they can go to the Google Analytics documentation site, copy and paste the snippet, paste it into this little WYSIWYG editor. Also, what they could do is find a 14-year-old Stack Overflow answer and paste some JavaScript from that and put that straight in the tag manager. So a tag manager is a conduit to live environments, right? It's production JavaScript. It's not production quality JavaScript, no way. But it's a way of people, usually marketing teams, getting code onto a live environment while skipping the entire development process. This is why engineers very rarely realize how severe the problem is, because they haven't written 90% of that code. It's been copied and pasted from around the web and deployed via a tag manager. So yeah, if you've got a tag manager running on your site, that's probably why third parties get out of hand. They're generally a good idea if they're well managed and well governed, but when they aren't very well governed, we do end up with this. So I'm going to split this talk into 4 key parts. Understand, so what are the risks we face? Audit, how do we measure the risks that we're facing? How do we discuss those risks or the problems with third-party providers and indeed our own internal teams? And finally, mitigation, how do we design around this stuff defensively? So understand, and when we talk about understanding, I'm going to start with the thing that I understand the least, which is security, right? I'm not a security expert, I'm not even a security novice, really. So we'll blast through this one quite quickly. If you're using third parties, you're basically just inviting somebody else onto your site, right? And a lot of that just is trust. You have to trust that Google Analytics will continue to be an analytics tool and not start doing anything more shady. You've got to trust that Typekit is only going to send you a font and maybe not start sending you other things and selling data to other more kind of nefarious third parties. So when we look at security, we want to be careful of things like linking to insecure origins, right? If you're running a secure site but your third party is insecure, things as simple as mixed content warnings, mixed content errors, will start to erode consumer trust. If you've got an e-commerce site and all of a sudden Chrome starts saying insecure, people aren't going to put their credit card details in there. If you're pulling insecure assets from insecure origins, you could be susceptible to a man in the middle. That third-party asset could be compromised. Or the last point is maybe the third party isn't actually a good actor at all. Maybe it's just a kind of sleazy third party. I've got an example of that in the next couple of slides. So last year, I went to Iceland to speak at an event. I look really weird just staring at you over DevTools there. And I always buy the in-flight Wi-Fi. I can't believe we can fly full stop, right? The fact we can get internet up there, I'm a mug. I always pay for the Wi-Fi, even if I don't need it. This was a brief period where my site was accessible either over a secure or an insecure connection. It was a transitional period. If I visited my site over an insecure connection, you may notice there, just above DevTools on the right, was an Iceland Air banner. This is a thing that would pop open periodically and tell me, hey, if you buy a coffee, you get a free biscuit, right? And it was advertising to me. I was getting man-in-the-middled. Now, you won't be able to see this probably any further back than the first few rows, but in the protocol column of DevTools, I am being downgraded to an H1.0 connection. Their proxy server runs an H1.0 protocol, right? Over a secure connection, this site runs over H2. but being man in the middle was slowing me down. YouTube, this is a funny one. Well, it's actually not funny. It's funny as in pretty bad. YouTube were busted serving crypto mining ads last year. YouTube was recently caught displaying ads that covertly leech off visitors' CPU and electricity in order to generate digital currency on behalf of anonymous attackers. Sometimes a third party is just a bit of a scumbag, right? There's nothing to stop a third party just deciding to do something different or sleazy or inappropriate on a user's device. So at a minimum, make sure you're pulling everything from secure origins. Don't use a third-party provider if they don't run secure origins. A happy sort of side effect is that if we do run TLS everywhere, we get access to platform-specific features which only work over HTTPS. So we can get H2, Service Worker, and Brotli. These are only available over secure connections, and these are all performance-oriented features. Next thing to be aware of is delays. Right? It doesn't take me to tell a room full of engineers that on the web, especially e-commerce, time is money, and any slow-running third-party or even first-party will leave you susceptible to losses in revenue, engagement, conversions, whatever your KPIs are, you're at risk. The delays could be on the network between first and third-party origins, congested network, sort of low bandwidth, whatever it may be measured as. It could be actually on the network. There could be third-party infrastructure problems. Maybe your CDN is being DDoSed, right? Or maybe they're having an outage, maybe they've gone down. And the one we don't think about often enough is, what if it's third-party runtime cost? What if the assets haven't been optimized? What if the assets haven't been sort of very well structured? This next slide's a little bit meta. This is me quoting a client, quoting a third-party provider. My client runs an e-commerce business, and he was concerned that one of the third parties they were using was slowing them down. So they got on a phone call. My client, Ryan, rang the third-party provider to sort of say, hey, I think you're slowing us down. The provider very naively responded, there is zero performance overhead to using our synchronous script. Our typical response time is around 200 milliseconds. My first thought is, well, which one is it? Is it 0 or is it 200 milliseconds? Because it cannot be both. But 200 milliseconds in web performance terms is eons. That's unacceptable. That's way too long. A client of mine back in the UK, Trainline, we worked together on this project. We found by reducing latency by just 300 milliseconds, customers spent an extra £8.1 million every year. So by proportion, sort of working it backwards, 200 milliseconds would be worth 5.4 mil to this company. For Mobify, 200 milliseconds would equate to increased revenues of $750,000 a year, so not quite 8.1 mil, but it's a hell of a Christmas party, isn't it, right? With $750,000, you wouldn't say no to that. And this one's my favorite, because this is eye-watering. So Walmart, for every 100 millisecond improvement in performance, they saw up to a 1% increase in revenue. So I did a bit of really sort of scrappy, back-of-a-napkin maths. Walmart is so filthy rich that taking just their 2017 e-commerce only revenues, so we're not talking retail, we're talking e-commerce only, a 200 millisecond increase in performance would be a 2% increase in revenue, and a 2% increase in e-com only revenue for Walmart would be $230 million a year. So that 200 milliseconds doesn't seem quite so innocent after all, does it? Let's go one further. Let's imagine there isn't just simply a slowdown between first and third parties. What if the third party's gone offline completely? What if we've got a single point of failure? This is when it gets really bad. If you've got a synchronous third-party script and they have an outage, you are royally screwed. This is a client of mine, and again, for people at the back, this will be a little hard to make out, but I'll try and talk through it. Client of mine, Sky, they're a big broadcaster in the UK, so we've just visited sky.com. You can see in the address bar we've made a secure connection. However, in DevTools, we've got a JavaScript file here that just says pending. That's because this is a third-party JavaScript file on a domain that's suffering an outage. Now look at the title bar. It just says the URL. As a civilian, as a regular internet user, this site just looks like it's down. But the reason it looks to be down, looks to not be working, is because, I'll make the text a little larger, I think, in a second. We've got a third-party script here on a domain that is currently suffering an outage. A third-party script is a synchronous script is parser blocking. the parser can't even reach line 11. The parser can't even read the content of the title tag. We've got all the HTML on the device, all the content is on the device, but this synchronous third-party script that's having an outage is stopping the parser even reading the content of that title tag. So pro tip, make sure your title tag's quite early in the head, just to avoid this problem. But look, to a consumer, to a regular user who doesn't know what DevTools is, doesn't know what a TCP timeout is, this site is just basically down. It's going to remain down for 80 seconds, because that's just how the browser works. After about 80 seconds, what you will see is the page just sort of springs into life. This is a TCP network timeout error, and that is defined by your operating system. So on a Unix machine, it's 80 seconds before the browser is like, well, yep, I'm going to just move ahead and forget that file even existed. On a Windows machine, you're looking at 20 seconds. So on a Windows machine, it's a little more forgiving. But we just showed a customer a blank page for 1.3 minutes. No one's going to wait around for 1.3 minutes. They're going to go to a competitor. They're just not going to bother. They're not going to wait for that. Now, this problem isn't specific to JavaScript, nor is it specific to Adobe Tag Manager. If you link to link rel equals stylersheet fonts.googleapis.com, which we all do, if Google Fonts has an outage, the exact same thing happens to us, 1.3-minute load times. And for that 1.3 minutes, we can show nothing at all, because CSS is a render-blocking asset. So yeah, outages are severe. They don't happen very often, but when they do, they are critical. So now we're understanding some of the risks that are sort of posed, like loss of revenue, loss of conversions, outages, delays, etc. How do we measure it? When I do performance audits, I normally spend sort of 5 to 10 days just auditing a site. I will usually spend about half a day just doing third-party stuff, and I'll show you a quick introduction to that now. The first thing I do is very non-scientific. I just get a rough idea of how bad the problem might be. Basically, what I'm trying to work out is, do we need to dedicate more time to third-party auditing or not? If you've got your phones handy, I'd recommend taking a picture of this slide. This is one of my favorite tools. So we're going to come back to this, requestmap.webperf.tools. It's a really good way of getting an overview of all the different third-party assets coming from a particular page. Before I dive into this, though, my workflow is very specific to me. I go off and run a web page test. So if you haven't used web page test before, I'd recommend this is your sort of weekend homework. It'll just grab some stats about how a page loads, and it'll give you a unique ID. Then you're just going to plug that ID into requestmap. So you need to take that ID, stick it into the URL, and it gives you what me and my clients have lovingly named the jellyfish. Now, what we're looking at here is a bit of very sort of broad overview data viz. The size of each blob, let me rewind a little bit. Each blob represents a third-party domain. The size of each blob represents the number of kilobytes from that domain. The distance between the blobs represents the time to first byte between those domains, so basically the latency. And the thickness of the line between each blob represents the number of requests between those domains. So you can get a really good overview of how many third parties you're using, which are the biggest, which are the most expensive. This is great for non-technical parts of the business, right? So marketing teams, etc. It sounds really patronizing, but I do feel like a good bit of data viz it's worth 1,000 words, right? But as engineers, we want access to the data, which is lucky because bottom right-hand side of this screen, we've got access to the CSV. It gives us a nice little spreadsheet of key information about each of those third-party origins. Don't laugh at me, I don't write much awk. To be honest, I don't think anybody writes much awk. But I managed to type until I got this one-liner that seems to work. If you run this over the CSV, it will pull out every single third-party domain into a nice little list. So you can just get a list of every third-party domain that page is calling. Then we can go back to web page test. This is why it's a key part of the sort of the workflow. Web page test has got this really nice feature called block, and you can paste a series of domains into this text area. And what it will do is it'll rerun the test with all of those domains missing. What I'm basically doing here is proxying the rough cost of all third parties. Do a test with all the third parties enabled, do the same test with all of them disabled, show me the difference. And it will just block all of those requests. I'll just pull this into a simple chart, and I'll have this in my sort of kickoff meetings with clients. And what we can see here, this is the CNN homepage. Interestingly, CNN is used for every single performance talk example, so they should have the fastest website in the world. But they don't, so they're clearly not listening. Now, what you can see here is the load time is dramatically affected by third parties, right? With the third parties present, load time is pushed back to nearly 10 seconds. Now, load time in and of itself isn't useful to customers, users, but if we've got any important events hanging off of the load event, like our image lazy loader, for example, only boots after the load event has fired, we've just pushed that back by more than twice as long as necessary. However, slightly more optimistically, the delta between start render and speed index before and after is quite slim. What this tells me is that, very roughly speaking, most of these third parties are not blocking first render. So that's a little more optimistic. However, if we go and look at things like the number of requests, the number of requests was reduced by a factor of 4.2 just by removing third parties. Now, in a world of H2 and multiple domains, request is becoming less and less important. However, on low-powered devices, basically mobiles, provisioning new TCP connections and doing sort of simultaneous DNS resolutions does come at a cost. It has CPU cost, it has battery cost. So third parties can actually run down mobile battery quite badly. And then page weight, so the actual weight of the page before and after. Afterwards, it was reduced by 2.7 times. Now, for about 6 days, I'm part of the EU. After the 12th of April, and God knows what happens, data roaming charges might kick back in. And when I travel to, nearby we've got Serbia, I was in Ukraine last week, it cost me £7.20 per megabyte if I use my data roaming. $7.20 a megabyte, I can't afford to use the internet. This difference here between before and after was £15. If I'd have loaded the CNN homepage with all their third parties turned on, it would have cost me £15 more to view those third parties. And that's just horrible, that's sort of immoral if you ask me. Anyway, this is very extreme and non-scientific. So let's look at some more specific things we can look at, slightly more forensic. So yeah, let's go back to delays. Let's look at the delays problem again. Whenever we add a third party or audit third parties, we need to ask, what happens if Typekit is running slowly? What happens if Google Analytics is running slowly? A very important question to ask, and thankfully, a really simple question to answer. I'm going to use a tool called Charles. Who's used Charles before, Charles Proxy? Oh, sweet, like definitely a third of us. Those who haven't, Charles is great. It's free in the same way that Sublime Text is free, if you know what I mean. So I'd totally recommend getting hold of a copy. It's got this really wonderful throttling feature. I wonder if I can... Yeah, so throttle settings, you can start to pinpoint specific origins to slow down. Chrome's little throttling feature is all right, but it will just throttle that entire tab's worth of requests. With Charles, you can actually start to run specific origins slowly. So you can add Google Fonts to this, you can add Typekit to this, and run just that domain as if it's on a 2G connection. Again, going a bit more severe, what happens if a service goes down, right? What happens if Adobe Tag Manager goes down? What happens if Google Fonts goes down? Again, very important question to ask, and again, thankfully, quite a trivial question to answer. Web page test make available to us a black hole server. Don't visit this IP address in a browser. It maps to blackhole.webpagetest.org, and basically any traffic that goes through this IP address through this server just disappears. It simulates a full-on network outage. When I showed you this screenshot earlier, Google Fonts hadn't actually gone down. In fact, I don't have time to go into it now, but buy me a beer and I'll tell you some interesting statistics about Google Fonts. But suffice to say, in the sort of 7 to 8 years it's been running, it's never had a single millisecond of outage. It's got 100% uptime. But still, it's worth auditing, because if this does go bad, it goes really bad. Missing files. This one's often overlooked, especially in the world of kind of fully client-rendered JavaScript applications. I've got a slightly controversial opinion, and it probably won't be too controversial here at JSHeroes, but let's go for it. A buddy of mine a few years ago said, all of your users are non-JS users while they're downloading your JS. And I completely agree with this. Every single user, for at least a short period of a page load lifecycle, doesn't have any JavaScript. Because until that JavaScript arrives, successfully is parsed and executed, and runs, they're non-JavaScript, right? Now, the controversial bit is this. I don't think we should ever optimize for users who have disabled JavaScript. If somebody has turned JavaScript off, they knew what they were doing, right? And they opted into that. 99.9% of the web will not work for somebody who's turned JavaScript off, so it's kind of weird for us to go out of our way to make our site work for them. Also, another way of looking at it, because developers like statistics, I can almost guarantee you have more IE6 users than non-JavaScript users. And you don't support IE6 anymore, so statistically, it'd be weird to support people who've turned JS off on purpose. Very keen to stress on purpose there. Because what we should think about is, how well does our JavaScript fail? What happens if app.js fails to arrive? What if it arrives but there's a fatal syntax error in it? What happens if it goes wrong? How gracefully do we handle that failure? And you might think, well, this isn't going to happen, or it's such an edge case, it's probably never going to happen. A few years ago, something fascinating, like one of those things where it's just a massive facepalm moment. T-Mobile, the cell provider, broke the internet for hundreds of thousands of people. Most cell providers will proxy content you're browsing through their own servers, and they will do optimizations for you. They will look at an image and think, oh, this hasn't been optimized. I'll optimize it for them and pass it on. Oh, this hasn't been gzipped. I'll gzip it for them and pass it on. Their minification script was a bit overzealous, and it opened jQuery and found a start comment, /star. Think, well, someone hasn't deleted this comment. I'll do it for them. And it started deleting jQuery until it got to the closing comment, except there was no closing comment because this was actually a string. It was a regex. /star was an irregular expression. It never found a closing comment, deleted 2/3 of jQuery, gzipped it, sort of dusted their hands thinking they'd done a good job, and sent off. I mean, yeah, it was fast because there was only 1/3 of jQuery left. But it broke almost the entire internet for hundreds of thousands of T-Mobile customers. If you want to audit this and test for yourselves how resilient your site is, again, modern tooling makes it very trivial. Find the asset you're interested in. Here we've got vendor.js. Right-click, block request URL. Every subsequent refresh for this page will not request that asset. And you can see what happens if anything has gone wrong with vendor.js. Me and my clients soon realized that we didn't handle it very well. We gave the customer an infinite loading spinner. We can easily defensively program around this. If the app hasn't booted after 10 seconds, request that the user refreshes the page. It's not graceful, but it's slightly more graceful than this. I'm going to have to start hurrying up because I'm running low on time, but runtime cost. What happens if there wasn't an outage? What happens if there wasn't a delay? What happens if your JavaScript did boot successfully and it is running? But what happens if it's expensive? What I tend to do here is in Chrome's DevTools, I will run a performance profile, and there's a little drawer that says summary. If you look inside summary, you can find a thing called bottom up and then group by domain. And that will show me this. Now I can see which domain has the most runtime cost for this page. This is a client-rendered React application. It makes complete sense that sportsbet.io is the most expensive. The first-party code is the most expensive. That tells me that I don't have to worry too much. Although Tag Manager being 25% of the overhead is kind of concerning, right? So I want to investigate that. Why is Tag Manager 1/4 of the runtime cost? Let's do group by URL instead. Show me which individual file. It turns out this client's Tag Manager is more expensive than all of React. That's terrifying. The runtime cost of this one Tag Manager, which is only there for third-party stuff the user doesn't care about, is more expensive than all of React. This tells me that I need to have a look at this. Another nice thing here is we can scrub this view and have it update in real time, and you'll see that for the initial sort of first part of the page load lifecycle, Tag Manager was taking majority of CPU cycles. Tag Manager is getting run ahead of React, ahead of the first-party application, so my simple fix there is we need to defer these third parties. Don't give CPU cycles away to your Tag Manager before you've even started to boot your own application. Next bit is discuss. This is the hardest bit of the whole process because everything we just looked at is a technical problem, and technical problems have technical solutions. Discussing this with people is a lot harder because egos are involved, people's livelihoods, people's jobs. You can't just rock up to a marketing team and say to them, hey, everything you do every single day in your job makes this site a little bit worse. They're not going to like you for that. It's my job as a consultant to have a lot of those awkward, difficult discussions, and the one I get all the time is, oh, it's a necessary evil. We don't want to use this Tag Manager, but we have to. We don't want to use this, but we have to. I hate this. This is so lazy, because you need to really drill down as to what necessary and evil actually mean. It's nowhere near as black and white as that. It's very artsy, that, isn't it? Because I said black and white, and this is now black and white. Necessary, right? Is Google Fonts necessary? Probably not. It looks nice, but we can deliver a product without a custom font. Is Google Fonts evil? Absolutely not. It's a font service. Is a crypto mining bit of software necessary? Not really. Is it evil? You better believe it. So we need to drill down really which individual third parties do we need? What do we need to run a successful business? And you might find that analytics is necessary. You can't improve what you can't measure. But if you're capturing things that would make a customer uniquely identifiable, maybe that is straying into the evil category. So we need to drill down and be a little more rigorous with how we treat these things. Discussing with vendors, discussing with third-party providers, my biggest bit of advice here is double, triple check that they are problematic before you get on the phone to them. Nothing more embarrassing than complaining to a third-party provider that they're slow, only for them to tell you that you've implemented it wrong, right? So double, triple check yourself. Form a hypothesis. If you think a third party is running slowly, they probably are. Gather the data. Make sure you've got a lot of data to prove the point. Do the before and afters. Capture the timeline traces. And then thirdly, lastly, let them know. And there are sort of a multitude of different ways you can get in touch with third-party providers. It could be something as basic as a support ticket. So you'll probably find Google product forums for sort of things like analytics. If you spend a lot of money with that third-party provider, there's every chance you can pick up the phone and speak to an account manager. If it's a third-party dependency, we looked at a lot of that in the previous talk, fix it yourself. A lot of my job is going through open source sort of dependencies of my clients, and I will submit the patches to make things faster or smaller or more efficient. And finally, if all else fails, take to Twitter, because if it's on Twitter, people start to panic. My ad provider, I asked them to add rel equals no opener to their links. About 6 weeks later, it had been deployed, done. DHL, the delivery company, were running an application over an insecure connection, asking for customer data. I let them know, hey, can you force this onto a secure connection? About 2 weeks later, done. Sometimes you get what are referred to as fourth, fifth, and sixth parties. So your third party might use their own third parties. Lotame, don't know if that's how it's pronounced, but never heard of them. They're actually a fourth party, right? And I've never heard of them, so I just found them on Twitter and said, hey, can you force this over a secure connection? Their CTO replied, if you can panic the CTO, well done, right? If they're listening. And he's like, yeah, we'll get it, we'll fix it. So if all else fails, take to kind of public channels, just try and get in touch with them somehow. I have technically gone over time, so I'm going to start speeding up. I'm going quite fast already. Internal teams, this is where I come in. This is where I normally have these discussions with my clients, and I have to sit with marketing and say to them, do you really need 5 tag managers? Or design teams, why have we got 25 fonts? The CSV we downloaded earlier, this is going to come back in use again. That CSV file, it's just a treasure trove of information. I've got a spreadsheet because marketing teams love spreadsheets. I'm yet to work out how to get this data into a PowerPoint, because if I can give a marketing team a PowerPoint, whoa. Now what this is, it's my site's third parties. I don't use many third parties on my site, but yellow, orangey kind of color, that represents duplicates. There is more than one tag manager, for example, or more than one ad provider. Red shows me severity, from white, completely white, through to really dark red. That's a gradiated who is the most expensive. So you want to tackle duplicates and severe red first. Now with the CSV that the Jellyfish tool gave us, you're going to file, import. This bit is oddly specific, but it's a very key part of the workflow. Navigate to the CSV file that request map gave you, and here's the important bit. Replace data at selected cell. When you do this yourself, I've got a copy of the spreadsheet as a template that you can have. Replace data at selected cell is imperative, because this will just drop the new data over the existing conditional formatting. And this is now what the CNN site looks like when we start to grade it. There's a really important column here that I haven't discussed. It's the last column, column H, and this just says notes. Because what we're going to do now is we're going to go to the marketing team or go to whoever's in charge of the tag manager or deploying these third parties and ask them. It's really important at this point to ask, don't tell. It could be quite tempting to rock up with this spreadsheet and say, see all this? I'm deleting that, right? That's not going to work. Ask, don't tell. So what we want to do is we want to learn why people use things. Arrange a meeting and start gathering insights. Can you tell me why we use this? Which of these third parties are business critical? Are there any third parties on this list we don't recognize? That's a really good one, because there's always something, oh, we've never heard of it. Well, delete it then. Here is the spreadsheet. If you want a copy of that, please feel free. I'm really sorry, I am going over time. I'm just going to wrap up the last part of the talk really quick. Questions we can do afterwards, I guess. Mitigation. How do we design around this? How do we stop this becoming a problem? It's all well and good identifying it, but how do we actually solve the problem? Loads of stuff we can do. SelfHost. I see people all the time linking off to MaxCDN's Bootstrap or code.jquery.com. Completely unnecessary. Don't do that. Self-host absolutely everything you can. Don't leave critical assets on somebody else's infrastructure. If you can self-host a file, absolutely bring it onto your own servers. Much safer, much quicker. So yeah, where possible, self-host any critical assets. Where it isn't possible to self-host them, say it's a dynamic file, like analytics that needs to be updated on the fly, make sure you load everything asynchronously. Whatever asynchronous loading strategy the provider has given you, make sure you utilize it. If they haven't given you an asynchronous loading strategy, that's a red flag. I would be very, very cautious of that third party because they haven't considered what happens to me if they have an outage. Fixing the Sky tag manager problem was as simple as putting an async attribute on there, load the page immediately, bootstrap this sort of, not lazily, but off of the critical path. Much faster, much more resilient. Resource hints. So every third-party origin we go to carries some kind of network overhead, DNS, TCP, TLS. On high latency connections, that can get very, very expensive, but resource hints give us a way to pay that cost up front, off of the critical path. What resource hints do is allow us to preemptively fetch or warm up connections. So audit your pages, font provider, social media, some analytics somewhere, some ad networks, and just pre-connect those origins. What this will do is it will do the DNS, TCP, TLS ahead of schedule off of the critical path. My site, before implementing this, we're paying this cost at the worst possible moment. We're paying this cost just before we need the file. And those delays will push everything back. By enabling resource hints, pre-connect, pay that cost up front, off of the critical path, and it's no longer just in time. Key thing here is only warm up frequent, significant, and known origins. If anyone wants to hear a really, really weird story about DNS in Chrome, buy me a beer, and I'll tell you. CSP, anybody using CSP? Not enough of you. It is actually quite tricky to implement. Content security policy. This allows me to whitelist domains and what kind of stuff they can send me. So by default, only the self domain is allowed to run things. I will only accept images from ImageX, and I will only accept script from Google Analytics. This means that ImageX, who's meant to be my image provider, can't all of a sudden start sending me JavaScript. I don't want them to change what they're meant to be sending me. Support for this is really good, so I would encourage you to look at implementing it. It allows you to whitelist who can send you what kind of things. I don't need my image provider to be sending me JavaScript, so therefore I can prevent them from doing so. Now, where CSP, Content Security Policy, tells me who can send what, feature policy goes a step further and tells me what they can do with that stuff. So a good example of this might be, nobody's allowed to autoplay anything, only I can use geolocation, and no one should be allowed to access the camera or the microphone. So I might whitelist Google Analytics and say, you can send me JavaScript, but they can't all of a sudden sneakily change what their JavaScript does and use the microphone because I've prevented that. Feature policy is very much in its infancy, but it's worth being aware of. SRI, who's used sub-resource integrity? Okay, very few. Responsible third parties should provide this for you. jQuery, CDN, they do this for us already. You just get given a hash of the file you're expecting, and at runtime, the browser will check, is the file you've been sent identical to the hash you were expecting to receive? This means that if anyone was to hack or proxy or man in the middle code.jquery and inject some nasty stuff on the end of jquery.min.js, this hash will no longer match, and you'll get a console error saying there was a violation. Now, I know what you're thinking. You're doing this at runtime sounds quite expensive. The average cost for doing this sort of hash checking is around 1 millisecond, so it's well worth doing. SRI support's pretty good. We're getting towards the end, I promise. A new spec, priority hints, allow us to indicate to the browser how important we believe a file is to the page. It gives us a brand new attribute called importance, and we can say, our ads is of low importance. Download our app.js with high importance, download the ads.js with low importance. The good thing about this is you don't need to tell your marketing team you're doing this. Just start putting importance low on all of their scripts, and you never need to tell them, basically. Okay, promise. This is the last part of the talk. Promise. The last tip I have got for you when it comes to defending and mitigating third-party performance issues is really, really lazy, and you're going to hate me, but it's just restraint. Get away by using as little as possible for as long as possible. Push back on your boss asking for a fifth analytics package. Talk your design team out of using a third font provider. Try and get by with as little as possible for as long as possible, and it makes all the previous 111 slides of this talk completely unnecessary. The biggest tool you've got in defending against third-party issues is not using third parties. Thank you very much for listening. You've been very patient.